The universe is vast, mysterious, and ever-expanding. For centuries, humanity has looked up at the night sky and wondered not just how everything began, but how it might end. With the discovery of the Big Bang, we learned that the cosmos had a beginning. But what about its finale? Will it fade into nothingness, collapse in on itself, or tear apart in a cosmic catastrophe? Modern cosmology has proposed several thought-provoking scenarios for the end of everything we know. These include the Big Freeze, the Big Crunch, and the Big Rip. Each of these theories is based on our understanding of physics, dark matter, dark energy, and the ultimate fate of cosmic expansion. In this video, we'll dive deep into each theory, exploring the science behind them and what they mean for the universe and for us. The Big Freeze. Also known as heat death, the Big Freeze is currently the leading theory supported by most cosmologists. It stems from the observation that the universe is not only expanding, but doing so at an accelerating rate, a phenomenon widely attributed to the mysterious force known as dark energy. As this expansion continues over unfathomable periods, trillions upon trillions of years, the cosmos will grow increasingly vast and empty. Galaxies will drift so far apart that the light from one will never reach another, effectively isolating each galactic island in darkness. This growing distance between celestial bodies will gradually bring an end to star formation. The hydrogen gas necessary to ignite new stars will become so diffuse that it can no longer coalesce under gravity to form dense, hot cores. Starbirth will cease. The universe will enter a phase of stellar senescence, where no new stars are born and the existing ones begin to die off one by one. Our sun, like many others, will eventually become a white dwarf, emitting a faint glow before cooling into a black, invisible cinder. Other stars may end their lives in more dramatic ways, collapsing into neutron stars or forming black holes. Over unimaginably long timescales, even these remnants will fade. White dwarfs will cool to absolute zero. Black holes will lose mass through the slow process of Hawking radiation, and neutron stars will gradually decay. The universe will be left with an ultra-thin soup of subatomic particles, slowly dispersing as there is no longer any structure to contain them. No planets, no stars, no galaxies. Only a dim haze of fading energy. In the final stages, all matter and radiation will be spread thin across an ever-expanding cosmic void. Temperatures will approach absolute zero. Time itself will seem to lose meaning in the absence of change or interaction. No energy gradients will exist to drive thermodynamic processes, which means no potential for work, life, or even memory. The cosmos will have reached a state of maximum entropy, perfect disorder, where everything is so evenly spread out that nothing meaningful can ever happen again. This vision of the end is haunting not because of violence or chaos, but because of its quiet, inevitable silence. There are no fireworks, no cosmic clashes, just a long, cold drift into stillness. It's the ultimate expiration of time and structure. And while it may seem far removed from our present-day concerns, the Big Freeze remains the most likely end predicted by current models of physics. It forces us to confront a fate not marked by explosion, but by absence, a slow dimming until even the last flicker of light vanishes into darkness. The Big Crunch is, in a sense, the mirror image of the Big Bang, a cosmic rewind where expansion is replaced by contraction. This theory suggests that if the combined gravitational pull of all the matter in the universe were strong enough, it could eventually overcome the current rate of expansion and reverse it. In this scenario, galaxies that are now flying apart from one another would slow, stop, and then begin falling inward. What follows would be a slow but relentless collapse of everything in existence. At first, the process might take billions of years, barely noticeable on human timescales. But as gravity takes the lead, the acceleration of the collapse would increase. Clusters of galaxies would start to merge, stars would get pulled from their orbits, and entire galaxies would be torn apart as they spiral toward a central convergence point. As space contracts, the temperature of the universe would begin to rise dramatically. Radiation trapped in the shrinking cosmos would become more energetic, heating the entire universe to unimaginable levels. Eventually, everything, planets, stars, black holes, and even atoms, would be crushed together into a single ultra-dense singularity, perhaps resembling the conditions at the beginning of time. The laws of physics as we know them would likely break down. Some versions of this theory suggest that the Big Crunch could be followed by a new Big Bang, creating a cyclical universe that is born, dies, and is reborn over and over again in an endless loop of creation and destruction. This concept has deep philosophical and even spiritual implications. It suggests that the universe, like nature itself, could be governed by cycles rather than a single narrative of beginning and end. However, current astronomical observations, especially the discovery that the expansion of the universe is accelerating rather than slowing, make the Big Crunch seem less probable under current models. Yet science is always evolving. Unknown variables, like the nature of dark energy or undiscovered forces, could alter this trajectory in ways we cannot yet foresee. So while the Big Crunch may not be the most supported theory today, it remains a scientifically plausible and intellectually captivating possibility, one that forces us to confront the idea that the universe may not only have a beginning, but also a mirrored and equally dramatic end. The Big Rip is perhaps the most unsettling and violent of all cosmic endgame theories. It represents a universe that doesn't end with a whimper or a collapse, but with an unimaginable tearing apart of everything down to the very fabric of existence. The foundation of this idea lies in dark energy, the still mysterious force that is accelerating the expansion of the universe. Most cosmological models currently assume that dark energy is constant, but what if it's not? What if instead dark energy's influence grows stronger over time? In the Big Rip scenario, this hypothetical increase in dark energy means that space itself continues to stretch faster and faster, outpacing all gravitational, electromagnetic, and even nuclear forces that bind matter together. The first signs would be subtle, galaxies moving away from each other at increasing speeds. Then the gravitational pull holding individual galaxies together would be overwhelmed. Stars would drift apart, no longer held in galactic orbit. Over time, solar systems would become unstable. Planets, including Earth, would be flung from their orbits as the space between them and their stars expands uncontrollably. Moons would drift from their planets. The bonds that hold together stars, planets, and moons would unravel completely. In the final moments, possibly just minutes or seconds before the ultimate end, even atoms could no longer hold themselves together. Electrons would be ripped from nuclei, and the very building blocks of matter would dissolve into a frothing sea of fundamental particles. Eventually, space-time itself would reach a point where it can no longer sustain any kind of structure. Reality would shred at a fundamental level. Time would cease to have meaning. The universe wouldn't just become lifeless, it would cease to be coherent in any recognizable way. This final moment, the actual rip, could take place tens of billions of years from now, depending on the properties of dark energy, which remain largely unknown. While the Big Rip is a more speculative theory compared to the Big Freeze, it remains a valid solution within certain mathematical frameworks in cosmology. It poses some of the most terrifying and fascinating implications. Not only would matter be destroyed, but the very stage upon which matter and energy exist. Space and time would unravel as well. It's a theory that turns our intuitive sense of permanence and structure on its head and invites us to consider a universe that quite literally tears itself apart. Conclusion: while each theory paints a different picture, they all agree on one haunting truth. The universe as we know it will not last forever. Whether its conclusion comes in the form of a slow cosmic freeze, a dramatic gravitational collapse, or a violent unraveling of space-time itself, the end will be dictated by the fundamental laws of physics and the enigmatic force we call dark energy. These theories, though based on calculations and observations, remain deeply philosophical in their implications. They force us to confront the impermanence of everything, galaxies, stars, even time. It's a sobering thought. The vast cosmos, which has existed for nearly 14 billion years, might one day be reduced to nothing but cold radiation or fragmented particles drifting through an empty void. Our species, perhaps long extinct or transformed into something unrecognizable, will not be around to witness this cosmic finale. Yet the very act of contemplating it, of seeking to understand the mechanisms behind the universe's eventual demise, is one of the most intellectually ambitious things we can do. It reveals our deep yearning to grasp the truth of our existence, no matter how unsettling that truth may be. Studying the fate of the cosmos challenges us not only scientifically, but spiritually. It brings a sense of humility in recognizing how fleeting our lives are when measured against the cosmic clock. But paradoxically, it also highlights something extraordinary. In the brief time we have, we've developed the capacity to ask such monumental questions. Our curiosity, reason, and imagination have allowed us to peer billions of years into the past and project billions more into the future. The death of the universe might lie in a future too distant to fathom, but the existential questions it stirs about purpose, survival, and meaning are relevant right now. Whether we seek comfort in the possibility of a cosmic rebirth or reflect on the eerie silence of a frozen void, the search itself is what defines us as a thinking, wondering species. And perhaps in that search, we find a kind of immortality, not through time, but through understanding.